So, it's time to meet a friend of mine, the t-distribution. This is another table that you have. Get it out. You know what T stands for? Absolutely nothing, just like Z. It's just a letter. And the t-distribution is what you use when your sample size is small and you don't know the true standard deviation. All you've got is the sample standard deviation. It was invented about 150 years ago by this guy named William Gossett, who worked at the Guinness Brewing Factory. And he was measuring various properties of beer. They take their brewing very seriously there. And he had to invent new statistics to measure the beer better. You gotta respect someone who takes brewing that seriously. So, when n is less than or equal to 30, that's when you need to use the t-distribution. In fact, we have another formula. Does that look familiar? Of course it does. It's a lot like the first error formula we saw. But what's S? Remember, S is the sample standard deviation. And this, sigma, the Greek letter, population standard deviation. But other than that, the formulas are pretty much the same. S goes with T. Funny Greek letter goes with Z. And T is a number that we pull off a table, just like Z. Let's practice using the table for a while, and then we'll go do an actual problem with the distribution. In order to use the t-table, you need two things: your level of confidence and n. Let's say n is 17, and I want to make a 90% confidence interval. Now, look down the front of your table. You see DF. Across the top, you see levels of confidence. 0.50, 0.80, 0.90. Ah, that's the one we want. But what is this DF business? DF is degrees of freedom. Your sample size minus 1. So if n is 17, DF, you want 16. So you're looking in the row 16 and column point 90, and what number do you find there? 1.746. That's how you use the table. So if you want to make a 90% confidence interval and your sample size is 17, this is the t-value that you need to use. Let's try that again. Let's say n equals 24, and I want to make a 99% confidence interval. So I'm looking in the 0.99 column in row 23, because it's always n minus 1. So what's in that row in that column? 2.807. Okay, how about n equals 26 for a 95% confidence interval? What do you see there? Column 95, row 25, 2.060. Now, let's just look at this table for a minute. As you go down a column, what do you notice? Well, the numbers are getting smaller, right? What's at the bottom of the table? We got this weird row. Infinity sign. Then we get these numbers 1.645, 1.960, 2.326. Where have we seen these before? That's right. These are z-scores. The t-values are kind of close to the z-values. They're just a little bit bigger. And the bigger your sample size, the closer the t-value gets to the z-value. So essentially, the t-distribution is a modified z-distribution that it's just a little bigger to take into account the fact that you're also uncertain about the standard deviation. Okay. Let's study the mileage of sports cars. We want to know how fuel efficient are sports cars. We tested a random sample of 25 of them. We found a mean of 19.4 miles per gallon, which is really not very good, and a standard deviation of 3.7. Make a 90% confidence interval for the true mean. So, is this a small sample? Yes. 25 is a small sample. So we need to use the t-table. N is 25, 90% CI. So we're in row 24. $1.711. we find E. We got the T. What's S? Here it is. N 25. And then this works just the same as the other error formula. We evaluate it. And you get about 1.5. I'm going to round it to 1 decimal place because that's what we had in the original data. So, what do we do with that 1.5? Well, we give it and take it. So what's our sample mean? 19.4. And we subtract 1.5 and add 1.5. So that's going to be with, let's state this in a sentence, with 90% confidence the true mean is between 17.9 and 20.9 miles per gallon. Okay, got that? Good. Now, let's pause and think a little bit about the general theory of confidence intervals.